Bismillah ar-Rahman ar-Rahim. So today we will be discussing about the Darwin Designer and Darwin Collaborator. Basically, Darwin Designer we use for optimizing our water supply network. But basically, when we design water supply network, so the main component of a water supply network design is choosing the right type of pipe, dia, and material. For that purpose, so when you have a large number of pipes in a water supply network, to separately one by one going through the each pipes and checking its dia and material, and then checking the pressure at each node and junctions, it very time taking and cumbersome. So make this process easy and do it by efficiently. So we mostly use Darwin Designer. So I will use the Darwin Designer for this network, small network, to give you some clue about the Darwin Designer. So to open a Darwin Designer, you have to go to the analysis tab, and in that you have to open a Darwin Designer, and we will also discuss about the Darwin Collaborator after the Darwin Designer, inshallah. So after clicking on Darwin Designer, the dialog will open. It will show you some the manual or steps also, at how you will use that with Darwin Designer. So to use a Darwin Designer, first of all, you have to create a Darwin new designer study, where you have create some events, design groups, rehabilitation group, cost per properties, design type, and different type of notes if you want to add to that particular design study. So after creating a designer study, you will create an event for which you have to use the Darwin Designer, or optimize your water supply network. So for example, if you have created a number of scenarios, then based on that scenario, you can use the Darwin Designer and its study for this separately. So here I will use a base scenario. I will assume that I entered the average daily demand at each node, as I discussed in the, I think, in the fourth lecture, that I'm assume that demand for each node, but I will show you when I start the case study that how to choose the right demand for each node, and and how to calculate the peak demand and other stuff like that. So here I'm just taking a base scenario having average demand at each node. So first of all, I will define event. I will give him a name, and optimize. Okay. After renaming it, you can see that the start time, design time, start from time from start hours. You can basically the demand alternative. Here you can use different alternative if you want to use for this specific scenario. You can, for example, if you have defined a different topology and something else like physical alternatives, the demand alternatives, the fractional and edge cuts. So these are the different alternatives you can define for your specific purpose. So based on that, you can override these alternative. And when you define these alternatives, so by going to the uh, base scenario, by activating this scenario, you basically so basically you then, based on the alternatives you define, you change these alternatives based on what you have defined earlier in your alternatives dialog. So based on that, you change each alternative physical demand, initial settings, operational age. So based on that, you can then change uh, the alternative here as well for your specific scenario. So most of the time when you design water supply network, so we design for a peak month of the year and the peak week of the month, and for the peak day of the week, and for that peak day we basically design for the peak hour. So how we will incorporate these peaks month and the weeks, days and hour, so I will discuss you then in a separate lecture when I start a case study. So here basically uh, when you design a water supply network, you basically design for a peak period of time, mostly mostly at 12 p.m. at the daytime, and 6 to 5 to 8 p.m. mostly at the night time. So in these time periods, mostly the demands are very high. So basically you have to assign some multiplier in order to get the peak demand. So how to calculate that the demand multiplier, so I will show you that in the subsequent lectures. So here I'm just using a 1.5 to multiply each demand at each node with the 1.5 to calculate demand at each node. Here the default constraint you can give to the each node. So here I'm assuming the minimum pressure at each node is about 20 psi and about 80 psi having a maximum pressure at each node. You can also enable a consider pressure benefit. Basically, when we design water supply network, so we adjust two things: cost and the pressure. So if you consider pressure benefit, then you have to pay more. Basically, when you want to high pressure at at a specific node or for all node of water supply network, then you have to choose a rad dia or the high dia of pipe. So for that, the cost of a network increases. So no compromise on a cost, then you can use the pressure benefit. Or if there is a compromise on a price or the funds available with the client, so then you can disable this option. You can also the for flow, or you can also make a constraint for a minimum maximum velocity. So here I'm assuming a minimum velocity of 0.5 foot per second and a maximum velocity of 3 foot per second. Okay, so here after defining a event, you will define a different overrides. For example, boundary override, just like for example, if your network, you know about the network that some of the pipes, for example, this pipe is not properly working or closed in some time, then you can then design open and close to that specific pipe. Or you can also the status of the pipe or the open or closed status can also be given to the valve. If there is any valve involve you in your water supply network, then you can configure it here. So basically I'm not making any boundary overrides, so I will leave it here as it is. Demand adjustment, for example, if you want to add some specific high demand at specific node, for example for a fire flow, then you can add that also here. So I will use this after creating another event after using this event. So pressure constraint, for example, if you want to add a pressure constraint for a these uh, junctions, then you can add these as well here. So how to select these junctions? You will click this cursor button and then you have to select, or for example, if you want to do it for a specific junction as well, so then select these specific junctions based on your choice. So here by selecting all of the junctions of the water supply network, it show me the different junctions involved in your water supply network. If you want to override the default, for example, if we in a specific region you want to assign for example the higher value, for example higher value than 80 psi as a maximum pressure, then you can override these defaults value by taking override defaults. So I want to just the criteria same for all of the node, so I'm keeping it as it is. If you want to consider pressure benefit for a specific junction, you can then do it is also. We mostly consider pressure benefit for mostly the fire flow junctions, so you can do that as well. Flow constraint, you can also add a flow constraint. For example, if you want to add flow constraint, basically are designed to the pipe. So if you want to add flow contents constraint for those pipes, they just simply select those pipes involved in your water supply network. So it will show you all of the pipe involved in your water supply network. So these are basically the default values which I have defined here. So you can easily define the basically based on these default values. After selecting all of the pipes, the default value is assigned to each pipe. If you want to override the minimum and maximum velocity constraint, then you can override it easily from here. Okay, so the important step is to select a design group for what particular group of pipe you want to make a optimize run. This is very important. Most of the cases, first of all, one thing to remember that if you want to select a particular group for a optimize run of a water supply network, then minimum of 2 groups should be selected. In a group, a minimum of 1 pipe can be involved, but it's a good practice that basically when you design a water supply network, then the specific group of pipes that have great influence. Okay, I will just want to show it to you in a one note. It will be better to explain it in a one note. For example, I'm considering a dead end system. For example, I have a dead end system having a main pipe, and some of the sub mains are connected to these main pipe. So here I'm considering one pipe. Here I'm considering, so basically the main pipe mesh, I'm considering it is consisting of 3 pipes. Some of the pipes are then connected. The branches are then connected, or laterals are connected to these sub mains. So it is a good practice to the selecting by defining a specific groups in a Darwin designer. So the main should be selected as a different, so as a different group. For example, these pipes should be included in a different group. These the mains should be included in a different group, and the laterals and branches should be included in a separate group, because most of the cases when the Darwin designer you select these different groups. So basically the Darwin designer design basically the single die of pipe through that specific group. So therefore you have to choose a right number of groups in order to optimize the water supply network. Okay, I'm here. Here I'm just creating no, I want to create 3 groups. For example, for these groups, I want to create a specific group, and for these type of 2 pipes, I want to create a separate group, and for these 2, 3, so basically, I'm creating 4 groups in this scenario. So group 1 includes so to select a number of pipes in a specific group, you have just to click these ellipsis button. After clicking on this ellipsis button, you have to select from a drawing. So I want to select these pipe in group number 1. So 3 pipes are included in this group, and I want to select these 2 pipes in a separate group. and D. Okay. Okay, one thing to remember that for example, you want to design a water supply network and you are giving the the grow you are giving yeah, or you are designing each pipe to each group, then it is not good practice. It is not good practice to design in that way, because when you have a thousand of pipe, for example, if you in your network thousand of pipe are connected to each other in different way, or making a loops with each other as well. So basically, hydraulically, the Darwin designer will calculate the dia of these pipes accurately, but it will be not be practically applicable in a site, because it will calculate such that, for example, if you design each pipe to each group, it will calculate such that 6 inch of dia of pipe for this pipe, and then it will calculate a 2 inch dia of pipe like this. So irregularly it will calculate the dia of pipe. So it basically by connecting of 6 inch of dia with 2 inch of pipe, and then connecting 2 inch of dia of pipe with the 4 inch dia of pipe, so that basically it's not practically applicable in a site. So in order to design water supply net with Darwin designer, so specific group, that type of group should be that type of pipe should be designed to specific group that you should have experience, or you should know that most of the case, in most of the case, the dia of that group will be the same. So most the distance created based on your experience, but in a dead end water supply network system, mostly the upper end, the pipes coming from the upstreams having a high dia, and then at the moving through the downstream, the dia decreases. So based on that, you can also choose specific dia of pipe designing to the specific group. Rehabilitation group mostly use for the pipes. For example, if there are any for example, if you want to know about the how much cost will be required to for the cleaning of pipe, for the lining of pipe, or similar properties of like that of rehabilitating of the pipe of the existing water supply network, so you can use that rehabilitation group. So here I'm just designing or optimizing a water supply network. So I will recommend suggest you to go through it by yourself. Okay. So after creating a design group, you have to create the cost table as well, the different type of material if you want to design to each pipe. So I will create pipe cost table. Okay. So for here I'm using a ductile iron pipe. You can use also a different type of pipes in the Darwin Designer run, in optimizer run, like the galvanized iron, or the ductile iron, or the PVC or HDP pipe. So these different type of pipes you can also include in this. So here I am just using a ductile iron pipe. So after clicking this ellipsis button, you can the library will be open, and based on using this library, you have to select the ductile iron pipe. So by just clicking the ductile iron pipe, all of the properties related to the specific material will be shown here. Just click on that. So you can see here that Hazen-Williams coefficient, or for example, if you are using the Darcy-Weisbach equation, so the based on that, the specific values like C factor in the case of Hazen-Williams, or the relative roughness or fraction factor will be shown here if you are using that Darcy-Weisbach equation. So I will just I will just copy this. I will design a number of I will share you the cost table. Mr. Atula has shared with me some of the table. So I will share you with these tables with you after the class. These tables basically so you can get from different type of factories or company which will provide you when you are designing a water supply network. You can get this pipe dia or the price according to the that dia from the that respective company where you want to take these pipes rates. So I am here using 3 inch, 4 inch, 5 inch. I'm just assuming this. Basically, some of the dia may not be available in the market, so you have to choose those dia of pipe which are available in market. For example, if you choose that type of dia, if it is not available in the market, then it is useless to use in that water supply network. So it will be difficult for a contractor or a client as well to implement that in a field. So be practical in order to design water supply network. I will resume this purpose. Okay, after defining the cost table, you can then after defining cost table, you then will have to decide that you want to design based on the minimized cost. For example, if you have limited budget, then you can use the minimized cost in order to calculate the dia of water supply network based on the algorithm you choose. If you have, for example, if you want to design based on the available, you can insert the specific budget you want to use for a design of water supply network. Then you can use a maximum benefit. So basically, based on the maximum benefit, it will give more weightage to the pressure based on the price you give here in a debt. That here by just giving the price, so based on that it will calculate the pressures and pressure at each node. So you can also define a coefficient, pressure benefit coefficient in case of the maximum benefit and the pressure benefit exponent. So basically the algorithm used on behind of the Darwin Designer. So these are the coefficient exponent defined. You can here in order to calculate the water supply network dioxide. In order to define the exponent, you should not use this value much higher, because by using for example, use the exponent of 3 or 4, then it will make a much higher pressure constraints, which may make the which may make the design of water supply network uneconomical. So these values should be reasonable by entering in these boxes. You can also use the multi-objective trade-off. Basically, in this multi-objective trade-off, the Darwin Designer considers both the cost and pressure benefit, and in between these, it chooses a different solutions for you. So here I'm just using a minimized cost. I basically check the maximum benefit, and multi-objective trade-off is basically not working for this specific network. I don't know why, because it's not giving this feasible solution. So when I get to the case study, inshallah, when we use this and the case study, then we can check these two options as well. So after defining is the design events and design groups, cost properties, design type, I will then define the optimize run. You can also define the manual design run, and in order to calculate the cost of the specific scenario, then you can also calculate here. So I will just use optimize run. So here you have to define that which, for example, if you have define different events, then based on that event you can make active and deactivate that specific event events here in optimizer and dialog. Here you will assign the specific table you have defined in a previous dialog. So here we are not using a rehabilitation group. Okay, one thing to remember, this minimum of 2 groups should be defined in order to calculate the die of pipes in a water supply network. If you use one group of dia of one group of pipes, then it will give the Darwin Designer will give you the error that there should be 2 minimum of groups should be defined for running the Darwin Designer. So here they are the parameters for the genetic algorithm. The Darwin designers are using the genetic algorithm. There's a lot of research are doing on a genetic algorithm. So these are some of the parameters. So I will not go through this because I don't know that what that means. Basically, the programmers that the algorithm designed by different researchers mostly know about that very well. I will try to figure it out. So when I get to know that, I will let you know about these different probabilities and splice mutation, because the long histories and a lot of knowledge is behind these each parameter in order to define here. So I will keep this as it is defined by the Darwin Designer dialog, and here you can define the different maximum trials. For example, you can I just want to do it for a 25 to 25 to 50,000, and 9 improvement generations. Basically, when the maximum trial runs, when it gets a solution, it will make these trials again and again until it gets another best solution. So for 200 runs, if it not gets another second solution, a best solution, then it will keep the first solution as it is, and it will Darwin Designer run. So I will run this designer. So it's giving me the one solution here. I'm defining it. Here I'm defining that in order to keep the three to get me 3 solutions, but as the 209 improvement generations move through it, it did not find the other best solution, that the solution 1. So here it gives me the best solutions for these solution 1. So here you can see that bar from the specific table here where I defined the pipe dia and cost. So by using these dia and based on the cost, it minimizes and found the best solution for this water supply network, giving the total cost of the minimum cost for that specific network. It gives us the dia for that specific group. So we for group 1 we define 3 pipes, so it is a unique dia of pipe for that group. Similarly for the group 2 and group 3 and group 4. If you want to export this scenario, export these dia of pipe to specific scenarios, you can also check the simulated results here. So here we given our constraints. So based on these constraints, you can check that there's no violations occurs. So we get a good design here. And you can also check that there is some violations occurring, so then some of the pipes, the velocity. The mic किसका खुला है? Please mute your mic. If you want, here you can see that some of the pipe that they have selected, there is some violation because of the constraint we set here. So this is very small value, pressurized network, there should have some high velocity. So we should keep it as, for example, for a 5 and 6 feet per second in order to design water supply network. So you can check that these are simulated velocity based on this genetic algorithm. and this is showing that where it's making the violations. So I want to that export that these results to another scenario, to a separate scenario. You can easily export it from going to this blue upward blue arrow. By clicking on this, you can also create a report. It will create a report for you. Okay, so it will create a report. So I will give you a detailed lecture on how to create a report from WaterGem based on your core requirements. So this just a clue. Okay, you can, if you get a different solutions, that based on that you can get the graph that which is the best solution, or you can export it these specific dias that you have calculated to a specific scenario. So as exporting a scenario, you should also export these alternatives, physical alternatives. So physical alternative basically the dia of pipe, and the name of pipe it should also be the name of the designer should also be exported. So this is the basically optimized design, optimized design run. So always remember that the engineering judgment is better than the any computer algorithm. So if you uh, design a number of pipes, if you design a number of pipes in water supply network, तो ये बंदो मजा को बंदेगा ना मुक्ता साहिब. So you can export it to different scenario. The alternative should also be exported to that specific scenario. So I was talking about the engineering judgment. So if you design a water supply network and you calculate this pipe dia using a Darwin designer, then you should check also manually that is it reasonable that the dias calculated by the Darwin designer or not. So basically you will find some errors also. So you also use your judgment, engineering judgment, to select the specific dia for the specific network. So I will create another link here. It is going to end. So I will just export it to another scenario, and after that we will run that scenario. I'm going to stop sharing this.